In this video, you are going to be learning how to write and balance chemical equations. This is very important. Chemical equations, one of the fundamental concepts in chemistry, which you cannot do without. At the level of the university, you always need to write and balance chemical equations. Very important. So in the next few minutes, you understand what chemical equation is all about. You are going to understand why is it necessary for us to write and balance chemical equations. You understand the meaning of subscript and coefficient. They are not all the same thing. Many people always confuse between subscript and coefficient. You are going to understand the simplest rules or the simple rules which you always have to follow to be able to balance any perfect chemical equations. Without talking so much, let's dive straight into examples. I'm going to be giving some examples and we do a practical tutorial. That is when you are going to learn more on how you can balance it, because I'm going to explain certain concepts which you have to take note of whenever you are balancing any chemical equation. So we are going to begin with the formation of water molecule. That is hydrogen plus oxygen to give us water. The formation of water molecule. In this equation, you will see certain numbers. These are numbers called subscripts. Any number written below any symbol is a subscript to that symbol. But any number written in front of an element or a compound is simply the coefficient. So in balancing chemical equations, we add only coefficients in front of elements or compounds. We don't add subscripts. You cannot come and balance equation to write something like this. It's too under here. It's wrong. Don't write anything here. Don't write anything here. Only in front of this, in front of this. That is when you can add to balance a chemical equation. Before diving into how we can balance this equation, I want you to understand the meaning of chemical equation. When we talk of chemical equation, what is the meaning of that? If they ask you this question in your class exam, what are you going to say? Chemical equations. This is simply a symbolic ways. We're using symbols, symbolic waves to represent a chemical reaction. Symbolic ways of representing a chemical reaction is called a chemical equation. So in a chemical equation, we are using the symbols of the elements involved or the compounds. For example, A plus B. Let me say these are the reactants. These are what are reacting to give us C plus D. This is a representation of any chemical equation you always find. Chemical equation represents a chemical reaction. Generally, in the laboratory, we carry out chemical reactions. You simply take one compound or one substance and mix it with another substance. It gives us another substance which is known as a product. So if I have my beaker here and I have a compound like compound A, I take inside the beaker, put inside the beaker, take another compound B and mix it inside that beaker. If I mix the two together, they are going to react. There's a chemical reaction taking place in that beaker to give me my product, which is C plus D. The product are always different from the initial compounds that we're reacting. That is a chemical reaction. So let's go ahead and balance this equation. First of all, you have to take note of this. To balance an equation, you have to count the number of atoms on both sides of the equation. These are the reactants. We call it the reactants, and these are the products. Reactants are also on the left-hand side of the reaction, while products on the right-hand side, separated by an arrow which indicates the direction of the reaction. Even though some reactions are reversible, some reactions are both in the forward direction and in the backward direction, which are reversible. So let's balance this equation. You are going to write the elements involved, which are the atoms. As when we have atoms, the atoms involved on both sides, hydrogen here, oxygen here, and at the same time we are going to do that here, hydrogen and oxygen. You count the number of atoms on both sides. Hydrogen, how many hydrogen we have on the reactant side? You have 2 hydrogen. This subscript 2 indicates that we have 2 hydrogen atoms here. And how many hydrogen atoms here? We have 2, H2, which is 2 hydrogen. And you can see that hydrogen is balanced on both sides, right? Oxygen, now let's come to oxygen. We have 2 oxygen on this side, which is 2. And on this other side, how many oxygen do we have here? Only 1 oxygen. You can see that 2 and 1 are not the same. That is bringing us to the law of conservation of mass or atoms. Atoms are not being created or destroyed in a chemical reaction. It means that if you have 2 atoms of oxygen here, you should have 2 here, so that they should always remain the same. So to make them to be the same, you can multiply this one by a certain number to give this one. Multiply this by 2, it's going to give us 1 times 2 is 2. 2 and 2, they are all the same. So you are going to add these 2 you have multiplied with in front of the compounds we're balancing. After adding these 2 in front here, you notice that oxygen will now be balanced, but hydrogen is not balanced. You can see that these 2 in front here multiplies all the atoms in this compound. 2 multiplies 2 atoms of hydrogen and 2 atoms of oxygen. So hydrogen now becomes 4 here and 2 here. A difference of 2, 4 and 2, right? 4 and 2, you can make them to be the same. Multiply this by a certain number to give 4. So if you multiply this by 2, you are going to add 2 in front of this hydrogen you were balancing, right? So the final equation will be 2 hydrogen plus oxygen to give us 2 water molecule. This is a balanced chemical equation. After doing this, you can now count the atoms on both sides, and you are going to notice that they are all the same on both sides. So this is the simplest equation that you can always balance. So let's go to the next one, which is a little bit complex as compared to this. We are going to explain some principles which you have to always follow when balancing any chemical equation. Second example, we are going to balance the formation of ammonia. Ammonia is nitrogen reacting with hydrogen, right? Haber process, nitrogen with hydrogen to form ammonia. Let's balance this equation and see what happens. Nitrogen, you write the elements involved on both sides and count the number. So we have 2 atoms of nitrogen on this side. How many nitrogen atoms do we have here? We have only one. One nitrogen atom. You consider 1 and 2 are not the same. Let's multiply this by 2 and add it in front of what we are balancing. We have 2 hydrogen atoms on this side. How many hydrogen atoms on this side? We have added 2 here. So this 2 multiplies this 3 hydrogen atom, which is making up 6 hydrogen atoms. 6 hydrogen atoms here. So 2 and 6 are not the same. If we multiply this by a certain number, which is 3, it's going to make them to be the same. Hydrogen here is 2 times 3 is 6, and 6 is okay. So we are going to add this 3 we have multiplied with in front of what we're balancing, which is hydrogen. Our final equation now is going to be nitrogen plus 3 hydrogen atoms to give us 2 ammonia. That's how we can balance chemical equations. You can see that this equation is made of only non-metals, hydrogen and nitrogen. Even though hydrogen sometimes it gives out electrons to behave like a metal, but it's a non-metal. If you have an equation that is made of metals, non-metals, and some other compounds, you have to follow some principles to be able to balance those equations. For example, if you have an equation like sulfuric acid, you have sulfuric acid plus sodium hydroxide to give us sodium sulfate plus water. If you have this type of equation, you can see that there are metals in this equation and there are non-metals. This is a metal, this is a non-metal, and so on. You have so many non-metals, right? We'll start from the metal, balance in the metal phase, go to the non-metals, and lastly, you can balance oxygen and hydrogen at the end. Don't start with oxygen and hydrogen in an equation. It's going to make you to get confused. You never balance it. Sometimes you never balance it. If you are not careful, you cannot balance an equation like this. We are going to come back to this equation to balance this equation. Let's go to the next one, which is more complex as compared to the one we have just balanced now. Let's balance this equation: zinc plus hydrochloric acid. Zinc plus hydrochloric acid to form zinc chloride plus hydrogen. Zinc chloride plus hydrogen. That is an equation that we should balance. Let's do the same thing we have been doing. Hydrogen is also involved in this side. Chlorine is also involved. Zinc on this side, you have 1 zinc, right? This is zinc. You have only 1 of it. And on this side, we have how many zinc? We have 1 of it. It's also balanced. Zinc is balanced. So this is a metal. We start with metal first. Go to the non-metals and complete with hydrogen or oxygen. So we are going to go and balance chlorine first, which is a non-metal. Even though these 2 are non-metals, but we balance chlorine first. How many chlorine we have here? We have only 1 chlorine. But on this side, how many chlorine? We have 2 chlorine. So multiply this 1 by 2 to add in front of the compound containing chlorine, which is hydrogen chloride, right? Yes, when you add this, you can see that 2 chlorine is involved, 2 chlorine, and 2 hydrogen is not involved. This 2 times hydrogen, 2 times hydrogen. You can see that the last one is already balanced if you follow the same principle. Metals, non-metals, hydrogen, and oxygen. That is the principle you have to follow when balancing any chemical equation. Let's talk about the reaction of sulfuric acid plus a base, and it's going to give us sodium sulfate. This reaction plus water. This is a neutralization reaction, right? Neutralization reaction. So we are going to start by balancing our metals first. Look for metals on both sides. This is sodium, the metal, right? You go to non-metal, which is sulfur. Sulfur on both sides. You go to hydrogen. Let's talk about hydrogen. And lastly, oxygen. Oxygen on both sides.